Yes, Professor.
Good afternoon to all. On behalf of the organizing team and my own behalf, I welcome you all for the Faculty Development Program sponsored by Atal. It is a great pleasure for me to introduce our today's resource person, Dr. G. Saravanan, Department of EEE, KPR Institute of Engineering and Technology. He has completed his bachelor's degree in Electrical and Electronics Engineering from Periyar University and master's degree in Applied Electronics from PSG College of Technology and his PhD in Anna University, Chennai. He has around 15 years of teaching and industrial experience. He has received Best Employee Award at Griha Software Technology Private Limited and Best Teaching Faculty Award continuously for 3 consecutive years. He has published more than 35 papers in journals and conferences. His research area includes machine learning-based secure data analysis, electric drives, battery management, and IoT. We have an immense pleasure to call upon our resource person, Professor G. Saravanan, to share his experience. Sir, over to you, sir.
Okay, thank you, Professor. Professor, my screen is visible. Professor, my screen is visible.
Yes, sir. Yes, sir. It is visible.
Okay,
Sir.
okay, thank you. So, very good afternoon. So, today we are going to discuss about consequences and productions mechanism of battery management systems. Nowadays, just a minute. Professor, screen is visible. Okay, fine. Nowadays, the batteries is using in various applications. It includes solar street light, electric vehicle, smart building, stationary battery energy storage. So this 4 area is this focusing on batteries. Solar street light is everybody knows. So this is a smartphone architecture in solar systems. So this is a solar PVs. So in this pole, they are placed the battery at the bottom and the charge controller also. So in this smart pole, we can get the some informations like weather temperatures and the emergency contacts and sometimes we are charging these electrical vehicles and fixing the cameras, Wi-Fi access, everything is possible in the smart pole. But second one is electrical vehicle. This is the upcoming technologies in the present trend. So here these electrical technologies, especially in batteries, so we are using in all the vehicles. So instead of using this petrol or diesel vehicles, we are moving to an electrical vehicle. Today's sessions, we are going to discuss about completely about the electrical vehicle, how they are using this electrical vehicle, that is battery in the electrical vehicle, and how they are diagnosing this battery vehicle with the various sensors. Next one is smart building. This is almost all the houses are around 10 to 15% of houses is focused towards an smart building concept. The fourth one is an stationary battery energy storages. So this is the how we are normally storing the batteries for the backup purpose. That is a fourth concept. So now we are going to enter the concept electric vehicle with battery applications. So you just look this images. So here is the batteries. So you can see that this is called as a battery pack. So in this battery pack, it contains many units. One is an battery management systems, junction box, and the service disconnect switches, and more components. And if we are breaking this individual module, you are going to get one block is called as a module. It contains n number of battery cells. So that is this. Suppose if I am saying that 48 module in your for a vehicle, it contain that is each module it contain 4 cells. So you can multiply 48 into 4, that is equal to 192 cells in the vehicle that stores the energies. So just look what is the current trend and the futures mobilities about this electrical vehicle is we want to move to completely electrified. That means instead of using the fuel, we are going for an charge based vehicle, that is electrified, then automated, then connected vehicle. Connected vehicle means is automatically connecting the one vehicle with the other vehicle, that is communicating between the vehicle to vehicle. Okay, so that is this upcoming area, the future upcoming area in the electrical vehicle. Now these are all the part of the electrical vehicle. So one is basic structures, power unit, transmission systems, control, and auxiliaries components. Basic structures, yes, you can say some of this frame, suspension, axle, wheel, and so on. Next, power unit, that is a engine. Main part is an engine. So engine is an our power unit. Next, transmission system, that is gear and clutches. Then control part, that is a brake and steering. Then auxiliary means like headlamp, indication lamp, some other components. So you just look this figure and this figure, there is the difference between these two. So this our conventional arrangement. Here is the same structure we are connecting with this battery. So here the battery is placed either front or back of this vehicle. That depends on the places. So you know that the recent that is high end car is an Audi. So Audi S7, how they are placing the batteries, then how they are connecting. Those things we are going to discuss here. So you just look here. This is the power, that is battery unit. From the battery unit is connected to these various part of the uh, vehicle. Here, this color, that is there are different colors line shown here. So these are called as an buses. That means it's carrying the information from the battery to the components or these some of the ECU. Here the ECU means there are two things. So what here the ECU means there are two things. If you are considering the factor of mechanical, it is this engine control unit. If you are thinking about an electronic side, it is an electronics control unit. So here we are going to discuss about this electronics unit. So for an example, if you are taking about an air conditioner, so this is the air conditioner. You know that it is and some cooling arrangement is there, but it is connected to the battery via buses. That is, this is called about this CAN buses. So about this, we are going to discuss in these next slides. So in this batteries, you just look this battery. So this is the battery model. So this battery is an Audi A4 car. So this is a 12 volt batteries and it withstand up to 72 ampere hour. So this is the real model of this batteries. So this battery is how it's connected to this various part of the vehicles. So well, thinking about this ID car or some of this internet based electrical vehicle, we have in some autonomous systems. So for this autonomous systems, that means smart technologies concept, we have some symbols. Just look this figure. So these are all the some of this symbol is given. This is everybody knows this. This is the Wi-Fi symbols. This is a cellular symbols. So like that, we have the symbol that is a smart technologies icons they are used. Everybody familiar about then IoT symbols and IoT devices. They have this some IoTs smart devices symbols. They are marked in these devices. So if you are going for an there's connections or some of the sensor here, they marked that. So like energy consumptions, then it's recycling, like zero emissions, like that they are labeled in the places, you can easily observe in the devices. So if you want this, you have more than 88 smart technologies icons are there. You just refer this link, you can get this what are the symbols used for it, smart technologies. So here, if you are thinking about an battery, so battery management systems, we have the battery. From the batteries, we are placing the sensor here and measuring this voltage, temperatures like that. So from this one, we are developing an algorithm or writing an algorithm to predict our expected value. Suppose if low level is predicted, then we are sending the alert to the devices, then the issues will be avoided. How we are doing that? That is the concept involved here. First one is you want to collect the data from this battery. So how to collect the data from the batteries? With the help of sensor. So depends on this what the parameter you are going to measure. Based on that, you are going to place the sensor in the batteries. Next, this batteries is sending to the cloud. So the cloud, it may be this. There are two types of cloud. One is called as an, suppose if the manufacturer or the vendor is giving the free cloud access, you can use the free cloud access, or you can go for a third party cloud. So depends on your convenient, or otherwise you can go for an own server. So it is your wish, you can go store the data for your convenient. Next one is predict the potential maintenance and issues. That means you're predicting your level, that is a decided level, that is your algorithm part. Next, the notifications. The notifications to whom we want to send the data. Uh, that is your wish. Either it is a driver or owner or maybe the vendor. So with the connected devices. So how is we doing that? So for an example, this is our sensor part. So this may be the devices. It may be anything. So this is connected to this gateway. So these are all the gateway, and this is a cloud. From the gateway to the cloud, the data is sending, and this is our reporting. That means visualizing or analyzing the data. So here there are the four layer. While seeing this simple structure, you are going to get the four layer. One is this applications. That is this end is an application end, this end is an sensor end or the controller end. So this is generally called as an generally sensor or the controller. These are all these end devices. Next, this device areas is called as an network control, that is a gateway. Next, this is a cloud, this is called as a platform, and this is our reporting or visualizing our data, that is called as an applications area. So in this autonomous car, there are five level of autonomous. So level 0 is full zero autonomous. Level 1 is an driver assisted, that is a function specific. Then level 2 is a partially autonomous, that is automations. Level 3 is an conditionally automations but limited self-driving options. Level 4 is high automations. Level 5 is fully automations. So how is driving? You just look here. So in level 0 to level 2, who is driving the vehicle? So the human is responsible to drive the vehicle. Coming to level 3, that is human and vehicle is sharing the responsibility. So depends on the situations. This human will coordinate with the vehicle and drive this system, that vehicle. But this level 3 is very dangerous because it is very difficult to coordinate this man with the vehicle. So this is not a practicable one. So they are moving to the level 4 and level 5. So in India, level 2 is almost in the part. Then level 3 is not advisable. They are moving to an level 4. Next, what is the difference of this level 1 to level 5? So all the car, that is what the battery model I shown the previous slides, that is an Audi A4 model car. So what is the difference we are observing in each and every car? The only thing is that you just look this figure. So here, these are all the sensors. You just look here. This is a level 1 car. So level 1 car, you have only then two short range radar, and you have some of these devices like blind spot detections and land change assist. So like that, there is a small variations in the first one, that is from the 0 to the level 1. Then level 2 is the same thing, but one short range radar and two short range radar and one long range radar. Then coming to the level 3, so here it is in four short range radar and one long range radar. Coming to level 4, there are a four short range radar and four medium range radar and one long range radar. Along with that, we have a blind spot detections and also the land change assist. Then uh, rear cross traffic alert, and also this automatic emergency braking and adaptive cruise control and automatic uh, emergency braking. So these are all these specialties is involved in this level 4 automations. So level 4 is in your places, especially in the foreign country, they are implemented the level 4. So and the model is success, especially in German. Then coming to this level 5, this is fully automated. So in additional facilities, so instead of this radar range, so short range and medium range, we are going for an ultra short range radar. So and also here is an 360-degree object recognition is possible. So especially the vehicle to vehicle communications or the connected car. So this is the most preferable. So it may be plays a vital role in near futures. So how we are doing this? You just think about this electrical vehicle. So in this vehicle, electrical vehicle, we have an n number of sensors. So here is that is especially in India, around 50 to 60 sensors is in place, that is playing the major roles. But in foreign countries, they are implemented more than 150 sensor and producing these best results. But here, in each and every car, suppose if the car is having this 200 sensors, so it's generating this data of 4 TB per day in a car. Okay. In a car. So just look this car. So what are this part? That is, you can start from here. That is night vision sensor, head-up display, driver alertness monitoring, instrumentation cluster, then accident recorder, event recorder, auto dimming mirror, then interior lighting, then active cabin noise suppressions, voice or data communications, then cabin environmental control, then DSRC, environmental system, battery management system, land corrections, electronic toll collections, digital turn signal, navigation systems, security systems, active exhausters, noise suppressions, then active suspension, then hill hold control, regenerative braking, anti-lock braking system, tire pressure monitoring, parking system, electronic stability control, active yaw control, seat position control, transmission control, land departure warning, blind spot reductions, remote keyless entries, then OBD, onboard diagnostic 2, then active vibration control, cylinder deactivations, idle or start operations, electronic valve timing, electronic throat control, electric power steering, automatic braking, adaptive cruise control, adaptive front lighting, airbag deployment, engine control, and pedal control, then windshield and wiper control. So these are all the some basic sensors. So in this sensor, how it's connected to the battery, and if the battery fails, what will happen in the operations, and what is the protections to recover this. So we are going to see now. So this is some glimpse about an internet, that is IoT based is. things. So here, um, around 41 million of IoT devices going to implement by the year 2027. By the year 2023, 75% of the automobile will be connected to the internet. Every second, 127 devices are connected to the internet. Then especially this is because of the new technologies are upcoming data space, especially in this cellular. Here, 1.59 million of 5G cellular subscriber going to occur in the year of 2024. Then most of the companies are going to invest, especially in this IoTs. So we are expecting the year of 2023 around 1.1 trillion. Then the total economic towards an IoT would be the range of 4 to 11 trillion by the year 2025. Then home IoT market is expected to grow around 53.45 million by 2022. And also in 2024, the IoT is play the major role in healthcare, and it's producing this financial amount of an 150 billion dollar. So here, in this overall in industry sectors, 80% of the manufacturing industries planning this IoTs. Then we are in topmost developed countries. 60% of these US cities are investing for an smart cities, especially in IoT. It is support of IoTs. Then nearly 90% of the retailers are planning to use IoT to customize the store visit. So this is some of the basic statistics about this internet, that is IoT. So here, that is the huge investment. While thinking about this, here is an only 70 percentage going to connect with this automobile only. So you just look this here. So this is this IoT market growing regions. So this area, that is all the green color area, that is all Asian regions, they are going to develop lot by the year 2025. So this is the regions. Now you just think about this this vehicle, that is the major issues we are facing these areas. Yes, one is this part is a sensor part. This is this connected, that is a communication part. This is the cloud part, and this is the applications part. So here, this entire things we are segregating into some of the terminology here. These things, that is the sensor part, what we are saying, this is called as an edge devices. Then this part, that is GSM LTE, this part is called as an gateway. Next, this part is called as a cloud, and this part is called as an application part, that is web or mobile app. So this is this things. So how the data is transmitting like this. This is a sensor node. From the sensor node, we are sending to the cloud via this connections. It may be any connections. So about this, we are going to discuss in the next slides. Next, this is a web. So this web, it may be the mobile phone or app. So here, you just think about the car or the from the battery. So this regions. So either it is a um, wired mode or wireless mode. Most probably is this an wireless mode we are preparing, but in car it is an wired mode only. From the wired mode they are sending with the help of any one of this. So the communications part here is one is the Bluetooth technologies, next Zigbee, Z-Wave, near field communication, RFID tag, Wi-Fi, then 2G, 3G, 4G, 5G and LTEs, next power line, next Ethernet. So any using any one of this, we are sending the data to the cloud. So each and every communications technologies has its own drawback depends on our requirement, we can choose. So most probably, even in the higher end Audi car, they have this one app is called as Addy app, that is healthcare app. So they are using only the SIM card only. So they're not using other than this. So they are using only for this 5G. That is an SIM based one. Then coming to this this one uh, payment based or pay based parking system. They are using that NFC, near field communications. Then FASTag, you know that it is an RFIDs. Then some of the other devices they are preferring, but they are not in practical use. But Bluetooth is preparing for these speakering systems and so on. So here is some of the comparisons of all these technologies from 1G to this 5G. So you just look here. The only thing is an the bandwidth. Yes. So the bandwidth is the major concerns. So if you are going for an 5G network, it is an more than 1 gigabit per second. So that means the speed is high. So this is expecting, and they are using this 4G network. So this also at present they are using this one. Then coming to the network, these two are, that is 4G and 5Gs are the internet based network. Okay, then remaining things are all very simple. You just, I leave the slide, you can go through that. Next, this entire architecture, this IoT's model or the internet connected module is segregated into these 7 layers. So the first layer is the physical devices and controller. Second layer is the connectivity. Third one is an edge computing, that is a fog computing. Fourth one is an data accumulations. Fifth one is an data abstractions. Sixth is applications. Seventh one is collaborations and process. So here, this three layer, that is first three layer, that is physical devices, connectivity and edge computing. This layer, which is purely depends on the event. That means the sensor data. So you can say that it is a event based processing, that is real time data collections. Then coming to here data accumulations, it is only the storing the data, that is called as an storage stage. Next, this top three stages is called as an only data management and processing. So here it is an query based one. It is the data is stored here. From the data they are extracting the informations in different format, what the how they want to visualize the data for the further use. Now, so all this one, so you want to send the data to the cloud. So how we are practically doing in the vehicle, you just look here. So this is the vehicle model. It has a different ECU, that is electronics control unit here. So it may be the front lighting or it may be a brake, whatever may be. So this every block is called as an ECU. This here, this every ECU is connected to the battery of this vehicle. But the thing is that they marked as a different color. So you just look here, here is an blue color, then here is an red color, here is an yellow color, then here is an pink color. Like that, they are different color they used to mark or used to identify this ECU. So what it is? So here there are your 6 lines are there. One is called as an CAN. One is the CAN, that is control area network. Next one is a LIN, that is local interconnect network. Next one is an FlexRay. Next one is an MOST, that is media oriented system transport. Next one is an Ethernet. Next one is an OBD2, that is onboard diagnostic 2. So here in especially this FlexRay, MOST and D2B, these are all these advanced uh, things. So it is not in in the market, especially in India, but the CAN and LIN is in the market. So here is an the LIN is the data rate, that is data transferring rate is low. Then coming to the CAN, that is we have high speed CAN also. So especially in EV, they are using CAN till now for this data transmissions. So here in this CAN bits itself, it may be any color in this color, but they are giving the priority. So if it is a power line, that is a first priority. Suppose musical, some other line, it is maybe the second priority. Like that, they want to segregating these things. So for that purpose only, they are using the different color of line. Suppose if they are marking in the red color line, that means um, that may be the power train. So it is the most important line. Then it is connected to the CAN bus. Suppose if it is a musical systems, that is not yet too much of priorities, so that may be connected to the LIN systems. So like that, they are giving the preferences. So for different structures, they are using a different line. So you just look here, that is the color which are shown here is an blue, that is this LIN bus. Yes, that means this ECU is connected to the LIN bus. You just coming to the next one, that is a pink, and this yellow, it is a more that is connected to the CAN bus. The next one is an this is a flex array. So flex array bus. Next one is and this gray color is indicating this MOS bus, media systems. So it is depends on the a car manufacturer, that is vehicle manufacturer, they will give the guideline how to connect with the system. It is only for the guideline. And also you want to follow the standard code, especially while doing the service. This service engineer or the service boy is going to trace out your electrical connections from the batteries through this color coding of this wire only. Okay. Now, so it's communications. So the communication is, that is different layer. If it is a physical layer, we are saying that Wi-Fi or Zigbee or Bluetooth. So this is a protocol. Yes, sorry, here is IEEE. So IEEE 802.151. Then if it is a Wi-Fi or LAN, IEEE 802.11. Then if it is a Zigbee, 802.15.14. Similarly, coming to this network layer, that is a IP series. Then coming to the message protocol, that is message layer, that is application layer, that is MQT and HOPE XMP. Then coming to the transport layer, it is a TCP and UTP. Then adaptive layer, that is 6LoWPAN. So these are all the things. So now this is our data. From the data, that is sensor, from the sensor, the data is sent to the server or the cloud via gateway. Yes, this is the sequence. Now, model of various planes. So we are saying that there are 4 planes. One is called as an sensing plane. This is a sensing plane. All the sensor will comes under this categories only. Next one is an communication plane. This is the communications plane. This is the data planes. Next, while entering this sensing plane, we required an some of these authentications. That is either it may be the biometric or some barcode systems or some other mechanisms we can give as an input to operate this one, that is called as an security plane. Okay, so this is an applications plane where you want to do that. You just look these animations. One woman is searching the vehicle or booking the vehicle. So the vehicle is come to her places, and also the same thing will be monitored from the cloud from somewhere. Okay, so this is this applications. Now, in this engine control unit, you just look this car. We have an n number of ECU. In a single car, we have more than how many sensor you are using and how you are connecting to this ECU. So it is purely, it is depends on the car manufacturer only. So based on that, suppose for an example, so you just look this figure. Here is an engine, that is electronic ECU for an rear blower, ECU for tracking system, ECU for overhead console, then ECU for advanced front lighting, like this. So different ECUs are there. So they are placing this ECUs near to these components. Then 4 or 5 ECU is connected to the one more ECU. Then it's connected to the, that is grouping this ECU and putting on this one ECU. Then this may be called as an sub ECUs. Okay. So here I am, for example, I'm taking an ADAS, that is automation systems. You just look here. This is an car. So here is an, that is emergency braking, blind spot detection, road sign, then 360-degree view. Then this is the cameras, then a radar, that is front and back, then ASIL, land departure warning, then vulnerable user detects. So those things are connected to the single ECU or different ECUs. Again, it is purely depends on the manufacturer. So they will provide the data sheet to us. So you have to go through that. Then you want to identify that which ECU is it. So you just look here. So here we can say that, suppose if I'm applying the brake here, yes, yeah, I'm applying the brake here. Uh, our rear right want to display. So this may be the task. So here you can say that every task we are saying that it is called as an modular. Every task is this modular. Then the functionalities of this is called as an integrations. The next stage is called as an cross domain, or this cross domain means, suppose if I am applying the brake, that rear right want to display, that is called as an cross domain specific. Cross domain specific. That means more than two or more than one operations is involved in this ECU. That is an cross domain specific. Then domain fusions. That means multiple options. Then it is the same thing. There is many ECU are connected in this regions, that is called as an domain centralizations. Then it will move to the next stage, that is called as an vehicle fusions. Then next stage is an vehicle cloud computations. Okay, so this is the things, but it is purely depends on the, we could as a user we could not do anything. So it is from this manufacturer of the vehicle itself, they will give which one is belongs to one, which is you, they will decide it. So most probably they are going for an individual ECU rather than mixing the all this sensor in the one module. Now, so this is the block, individual block. So here is an, this is a ABS, this is electronic throttle, this is a transmission system, this is a steering. So this is a HMI, that is HMI is human machine interface. That means it is a diagnostic card is placed here from where you can take the data. Next, this is a parking assist sensor. This is a blind spot sensor. Next, this is a surrounding view camera scanning uh, leader. Next, forward facing radar, then front windshield and camera. So you just look here. So they are connecting some of the things with the common ECU. So this is a one ECU, this is an another ECU. Here I said that, so this ECU, it has only this one, that is parking, blind spot selections, surrounding, and also scanning this LDR ECU is connected to this blind spot. Similarly, for the forward collision is also connected to this one. That means this sensor input is taking this ECU and this ECU. That means cross domain. Yes, that means cross domain ECU. Look, the cross domain ECU. So in this model, you just look here. So this is the sensor. Yes, so you can connect a number of sensor for this. This sensor is indicating, suppose I am saying that here is this ECU. So this ECU consists of n number of sensor. Like that, we are coming to this sensor module. So temperature O2, then NOx, exhaust gas, throttle position, crankshaft sensor, and camshaft sensor. These things will be connected to the single ECU. So in this ECU, this output is given to this various part. The one is called as an instrumentation cluster. That is instrumentation cluster means that is a display. So how we are displaying the, that is viewing our data in the vehicle, that is a instrumentation cluster. So from the sensor, we are reading this real-time value through this ECU. Then sometime from the sensor value, you want to control the something. Suppose if you are applying the brake, the speed of the vehicle want to reduce. So in such a case, so you want to take the action. So that also possible. That is from the ECU is controlling an output. That is this side. Then the same data is sending to this onboard diagnostics. So here is we have the one ICC here. So it is recording the all the data that is called as an event recorder. So in this diagnostic board, that is it will look like this. If you are placing this that is corresponding cable, that either it may be RS-232 or HMI port, uh, you are going to extract the data what all the things are stored in the event recorder. Yes, so this is a on event recorder. Here is one block is there, that is says event recorder. Okay, so while seeing this ECU, the practical thing is it may be like that. If you are going for any service center, and if you are looking this by ECU model, it will be looking like this only. That is simply one aluminum uh, molded devices. It will be looking like this. Now if you are breaking this, or if you are removing this outer cover, the board will be like this. Yes, so this board will be like this. It is our either microcontroller board or the microprocessor board or DSP board. So but it has an n number of sensors which are connected to the board. You just look here. So this is symbol board. This symbol board, you just look here how many sensors are connected, and also the battery is also connected to this sensor. Now there are two things you have to think about these junctions. One is that if there is a failure in this any one of the sensor, the entire module operations is going to collapse. So you just look here. Suppose these are all the sensor, but unfortunately my air conditioning is not working, but the all other devices is working. That means the fault on this devices, then uh, that is this air conditioning, then all other devices is good means the fault on only for this line. I want to identify where the fault is occurred. So if you are searching manual operations, it is very difficult. So they have a separate software. Each and every car manufacturer, they have a separate software to diagnostic this, and also they are going to check the battery level also. So while seeing this, so what is the preference they are giving for an crankshaft sensor? The same preference is giving for this battery also. Yes, so you just look here in this board. uh, we have an n number of sensor. Either it is again depends on this number of input and output devices is connected to here. So most probably they have an embedded they have an embedded based board or DSP based board. Even nowadays they are moving to an AI board. You just look here. So these are all the sensors part. Yes, so the each and every sensor part I am going to mark it as an or name as an one of this um, name. You just look here. This is a sensor, this is actuator sensor, like that I am marking the line. So in this line I am connecting to this one of the ECU. Just look here, this is all my sensor. This is connected to this ECU. This ECU is connected to the diagnostics. Next you just look here. So these are all my ECU. So this is my inputs. So these are all the inputs. Each and all the input is connected to the CAN bus systems. From the CAN bus I am connected to the gateway. From the gateway I am connected to the diagnostic tools. So this is the things. Suppose if there any fault occur in the one module, suppose I said here this AC is air conditioning is a problem. So such a time, so the corresponding line will glow in a red color. So you can easily trace out that line and we can recover the block. Suppose if the fault is occur in the battery, then what will happen? The entire system is going to collapse. So how they are identifying that this batteries, we have only the two fault they are considering. One is an internal fault, next one is an external fault. Coming to the internal fault, either it is a overcharge, short circuit, then electrochemical reactions. Coming to this external, then crash, penetration, and heat source. So these are all the fault they are identified that. What is the hazardous of that? So these are all the hazardous. Then what is the response or what is the solution means? So these are all the solutions. So here, so if you are looking this short circuit, so the thing is that it is a short circuit is occur. That means some of the part is maybe melt. What is the solution here? You want to go for an corresponding locations and identify the fault. Either it is a hardware fault or the software fault. If it is a hardware fault, so they are going to replace. If it is a software fault, they are rebooting again. Now, while doing this, suppose if you are taking this gateway, that is this terminal, that is diagnostic part, and placing on the hub, it is going to display this some of the things like what is the model of the car, then what is the batteries model, those things, those informations is fetched automatically. Then from that one you want to do the diagnostics. For the doing the diagnostics, it is taking 4 to 5 minutes. Then the and also the part clearance is also occur 4 to 5 minutes. So but the thing is that on the onboard diagnostics, um, we can do any time, any places, but the anything connections means, suppose if you have the diagnostics tool in your mobile app, then you can do. Otherwise, you can approach the center, service center. So the major function of this battery management system is, one is to monitoring the conditions of an individual cell, then maintaining all the cell operating either within this tolerable limit, then protecting the cell from this tolerance level, then isolating the batteries in case of an emergency, then compensating for any imbalance of cell parameter within the battery chain, setting the battery operating point to allow the regenerative braking charges to be absorbed without overcharging the batteries, then providing the informations on the state of charge of the batteries. So sometimes this functions is called as an fuel charge. Then providing the informations for this driver displays and alarms, then predicting the range of possibles within this remaining charge either in the batteries, especially EV is required for this one, that is forecasting the charges. So if this charge level is this, so we can travel for this much of kilometers. The next one is accepting and implementing the control instructions from this other related vehicle systems, that is for vehicle to vehicle communications, then responding to change the vehicle in various operating mode, then recording the battery usage, especially is for the how many times is either it's on or off, then how many times the batteries is send the power to this corresponding ECU, that is called as a logbook functions. Then last one is an emergency limp home mode. So this is the most important, especially in the airbag system. Suppose if any accident is happening, this airbag is opening. So such a time the batteries should not get any fire. So what they are doing that they haven't some emergencies switches. Using that, they are going to cut off the batteries from the line. So if this battery power is disconnected from the uh, uh, disconnected to these corresponding sensor, many function going to malfunction. So we are moving to when some lean based or some emergencies systems in the car. Now you just look here. So this entire model most probably each So each dot here is indicating that ECU, then each ECU is connected to this one controller, that is called as a domain controller. This is a one domain controller, like this is controlled here. So in this ECU we record an board. So first thing is we record an speed. For that, the ECU itself is creating the delay in sometimes. So that want to avoid it. So for that, we are going for an some advanced board in the market. You just look here. So this is the first version, that is AutoStar Classic is the first version board. Again, next version board is an AutoStar Classic, but the speed is an high. Again, this is a third version board. This is a fourth version board. So till now we are using this version board only. Okay. Again, this board, that is SOP 2021, SOP 2025. These two are the AI based board. Okay. So the variation of the board, it is depends on the speed operations and also the memory operations. So even for this cipher physical systems, we are going for the higher end board. So this model is developing in Bosch engineering now. So what is there inside the board? So here is an every ECU is contain the board. So it is an single board, that is SOCs, system on chip board. So especially for this uh, battery management systems are the article. So we have the board is called as an Xilinx, that is ZY NQ 7000 series. So this is the board for used for an um, autonomous purpose. Here, there is possible to hack your data. Suppose I am storing the data in somewhere. So because it is connected to this devices or the internet, so there is possible to attack your data. You just look here. So this you may be placing the sensor in somewhere, from your car data is sending to the cloud. There is a possible to get an attack. So where to get the attack or possible area is, one is an ECU, next one is an onboard diagnostic, then third area is vehicle to anything. So it is also possible. Then ESP port. So in recent attack, that is malware attack is in especially IoT devices happening these areas. Okay. Again, this is a near field communications. Here is also possible to get an attack. Yes, because are hacking your devices. Again, for this, for automatic LAN changes, so it's possible to get an error due to this hacker. Similarly, for this steering control, also possible to get the ranges. So now, what they are going to do that? So most probably, uh, they are going for a secure model because of this model. Next, this is the connected car to car model. In this connected car to car model, here what we are going to do that. So they are going to use only for these four connections only. So one is a CAN bus, next one is on LoRaWAN, next one is on Wi-Fi. So CAN is an inside the car, it is a wired model only. LoRaWAN and Wi-Fi is the Wi-Fi module. So LoRaWAN is connect up to the 2 kilometer surrounding from your devices. So this is especially for these traffic light systems. This is most preferable LoRaWAN. Then Wi-Fi module. This is for us comparing to this LoRaWAN and Wi-Fi. Wi-Fi has less area uh, connectivities. So these three line connections only they are utilizing for the real time implementations. So this is our system. So how they are connecting with the BMS. So these are all the sensor. So this is single ECU. This ECU, it has an sensors. These are all the sensors. Okay. So here you just look here. So this is an BMS unit. Yes, battery management systems. So here you are connecting an battery unit. So this is powered either from this external charges or some from one other charges. So from this charges, we are sending the power to this corresponding ECU. That is, this is a battery module. From here is taking the power out. So from this power out, it is connected to these ECUs. Okay. So it's performing the operations. So it has an this ECU, it's connected to this devices. It may be anything. Either it may be the control switches, wheel speed, throttle controller, clutch, and power brake switch. It may be anything. Okay. So here, what will happen if one thing is failure or battery is failure in the vehicle? You just look here. So this is all the uh, problem going to occur in the batteries. You just look the first column here. So low temperature, low voltage, over current. It may be this any reason. It may be from anywhere. Yes, due to the function of or malfunction of anything, you may get this some of this error. It may be like this. So these are all the errors. What is the consequences of this one is due to this. These are all the consequence is going to occur. For an example, overcurrent is going to get an overheating. Suppose over voltage, you are going to get overcharge or overheating. Then sometimes electrode is breakdown due to this higher temperature. Then flammable gas may be released. So what is the solution for this? The solution for this is you just look here. Either suppose if it is a overheating, either fuse or BMS devices is going to damage or maybe blast. So the current will be shut off. So this may be the result. So how can you recover this? So likewise, you just look here. There are n number. Suppose if you are taking this EV, that is a vehicle, you have more than 50 sensor are used. So all the 50 sensor are connected to this different ECUs. So the battery is supplying this power to the all the sensors. If any problem occur in one line, so the corresponding ECU going to face these are all these problems. So now, if you are looking this entire final result, the operations most probably these are all the problems. But you just look here, it is grouping into 4 or 5 cases. One is pressure releases, next is current shut off, next one is an cooling on, next heater on. So like this, we have 4 or 5 major final results. So in a layman language, they are grouping this into 4 category or 5 category like this. Okay. So these are all this major temperature. These are all the 4 result operations. So how to they are doing in our implementation part. You just look here. So I will take one of this implementation model. So you can fix this that is temperature sensor in your batteries or in the battery surrounding your batteries. So from this batteries, you can measure the temperature variations. So here you can use the ThinkSpeak cloud. So and place this sensor. So every 2 minutes once, the sensor is send the data to the cloud. Okay. Then this data you can view only for this. If you're giving the option of private view, first you want to create the account in this ThinkSpeak cloud. I think most probably academician know about that ThinkSpeak cloud. So you can create an account in ThinkSpeak. Then you can view this sensor data. Uh, Next, if you want to share your sensor data to the others, you can give this a public view. Next, in this channel settings, so you can view in different format. Sometimes you want to view your result in graphical format, sometime in the kg format. Those things you can design this things. So it is a free cloud only. You can view, but the thing is that you can create maximum 5 channel, and you can receive the data every 2 minutes once only. Then your data can be import or export in Excel or CSV format for an further use. Just you clicking this button, you can view your data. So especially if you want to create the database, that is a data set, you can use this cloud. Next, you can come to this slide here. So these are all the problem. These problems I am grouping like this: either low voltage or over voltage, over current, over temperature, SCI breakdown, internal SAR, then electrolyte degradations, positive electrode, negative electrodes. So these are all these problems I faced in the batteries. So what is the consequences is, these are all the consequences. Then I am grouping the link like this. So if these are all the problems, this is my consequence, this is my action record, this is my final result. Suppose if I am getting an some problems like over voltage, next here is an dissolutions of an positive electrodes. Next I am going to uh, check for this BMS unit. Next process is an like cooling system. So like that, for each and every things I am segregating or grouping into 4 module. So the occurrence is grouping like this. So these are all the possible part in the batteries. So for these are all the problems, so these are all the consequences I'm going to face. If this is the problem, this is the actions. Suppose I want to go for an ventilations or want to go for release for this ventilations problems, I am going to release this process. So this is actions. So how could identify in the vehicle? That is the things. You just look here. Suppose if you are facing the problem in the vehicle, some any one of the sensor, so they have an ECU. This ECU has a sensor. Suppose this is my ECU. So you just look here. So I said these are all my sensor. Okay, this sensor has some unique number. That number is marked here. That ID is marked here. Then if the problem occur, the corresponding sensors, so that may be if you're connecting my car with these my systems or my diagnostic tool, so I will get this line like this. Okay, so wherever this fault is occur, it is highlighting in different color. So if I am clicking on this one, it shows this 4 options. So these are all my occurrence. So which occurrence is occurred? Suppose if I am clicking this, suppose if it is a battery, if I am clicking this, it shows what is the problem is occurred, or it is this problem is recorded in the logbook. That is event recorder. Then from the event recorder at the time of problem occurrence. So what is the problems in this one? Suppose if it is an low voltage or this over temperature like this, it may be some problem. So in these problems, what is the consequences is the heating. So what is the ultimate aim is, and we want to do this cooling. So like that is give the options. So if I am clicking this, it gives us solutions. You can uh, easily rectify that. Then coming to the one more thing, suppose if the any sensor is uh, damaged or doing the malfunctions, in such a case, if you want to change the hardware, it give the options like orders. So it will suggest the order which as the model is most preferable. Suppose the model is not available one, then it will automatically update the what is the another type of, or give the suggestions what is another type of sensors or the devices is can do the same operations. Okay, so that is the things here. Next one is, so this may be the futuristic systems. Here, all the homes uh, maybe use this solar PV. So you can use the solar PV, that is solar power directly from this your home. If you have excess power, you can send to the grid. In near future, you can use for an um, vehicle charge also. Okay, thank you.
Thank you, sir.
Thank you.
Participants, if you have any queries, you can ask the resource person. So since there are no queries, we will conclude it, sir. On behalf of the organizing team, I would like to thank our resource person, Dr.G.Saravanan, for sharing his valuable experience on the consequences and protection mechanisms of battery management system. Thank you, sir. Thank you for spending your valuable time. I also thank all the participants for your participation. Thank you. Thank you all. Have a nice day. Thank you, sir.